I wish I picked a room that had a TV.
Hey, do you want me to come around?
Yeah, why not? Or I mean, what's up here?
Okay, perfect.
It's really nice. It's here for audio because my computer does not do that sort of stuff. Okay, so my midterm review when I took this class a year ago is exactly the same as your guys'. He changed your homework a bit, but the midterm review is the same. So I just found my old one. As you can see by the top, it's on paper, so no computers, which kind of sucks. And there are occasional times you have to kind of write out SQL code. No one's going to kill you if you misspell select. But to know that select goes before you say from is pretty important. So those sorts of things. I know we like to think, oh, like we have ChatGPT and stuff, like it can do it for us, but you also have to know the right questions to ask and know that what you're getting back is correct. So basic stuff like that is still, a good thing to know, even in what is a simple test. And I don't even think we talked about inner joins, but in our class, we talked about them and it was confusing me. Like, I'm just not going to make sure they're not on there. So I would imagine midterm's probably pretty similar to what I took, but probably on inner join stuff. We know about some general concepts. So security, when it comes to security, what have we talked about in class? Because it is a little bit important, but what can we do? And maybe this was something we didn't quite get to, but whenever we talked about the SMU server, there's a certain level of security in there. And if you guys remember, you guys had like put in your, not your password and using it. Like, yes, that's a real thing, right? And the database actually manages all of that. So you didn't log in with your SMU account because it literally on the database, we can set up users on your computer that sign in with their own username and password, their own account. And for you guys at Macs and have to tap into it, you actually did that. And that's how you log into it. Where on Windows computers, it's smart enough to know, hey, the Windows user themselves is the owner of this and we can use it. But on Macs, you're virtually doing it. So it's like a whole separate entity. And other things is, gosh, I wonder if I can find this super quick because I think this is really helpful. I did a SQL workshop last semester. I don't know. Let's see here. Okay. No, there's an introduction to SQL. One second, where is it? Okay, SQL building workshop. So when it especially comes to security, one thing that's really important is this right here, where we're talking about the different levels in there. Can I? Okay. So there's a hierarchy to the levels of SQL, right? At the very beginning, we start with the whole server. So ignore what's on the left of the screen here, that's separate. But you have your server, right? You download that on your computer, that's the highest level. This is very similar to the way that your computer's file system works. So you have your computer and you have a file system on your computer. You can't go beyond your computer, so that's the highest level of the hierarchy. Mm-hmm. Where is all our data stored? It's all on our computers, or it's all on our server, right? A server is, in this sense, almost like a mini computer in its file system. That's all we're really doing is storing files. It's just not in a Word format, it's in a different format. So we have our server, highest level, then we have the database with our server. We have multiple databases, right? But that's the next level. Within that database, we have something called a schema. Now, this can be a little confusing because as you progress further in the program, you may hear schema used again in a different way. I don't know what genius decided to name this level schema, but schema can also mean like a blueprint or the like logical design of a server and like where all your tables are and what columns they have. That has absolutely nothing to do with the level called schema, which is where that security comes in. So schema, if you guys remember on the SMU server, we played around, maybe we created a table or two, but there was a prefix to your table. It was like your first two digits, some combination of first and last name, dot, and then your table. Well, that was that schema dot table part. So whenever we made your accounts on the SMU server, we also said, hey, give them their own schema, right? And so in terms of hierarchy, right, you get access to a server, you get access to the database, you get access to your schema, right? So we kind of, that's our starting point. So you get access to the minimum amount of databases you need to use your schema, and the minimum amount of server you need to use your schema. And then after that, you can only access the tables, columns, and rows that are assigned to your schema. So if you went in there, you can see that there's other students' tables in there. If you try to query it, hey, select from some other person's schema dot table name, it's going to go, you don't have rights to do that. It's weird, it will show it to you. That's like a thing that just, they will not let you do, but you cannot access it. So this is that type of security that he's kind of referring to, schema there. And then you can even go as far as put security on tables or columns and rows. That gets a bit more advanced. Usually that's handled outside of the server. If you have a user that you only want to see specific rows in a certain column on your SQL server, you're usually doing that in a different level, like a BI tool. But it certainly does exist and you can do it. But schema here is a layer within how we organize data that's purely just for security. At least that's what it's for. You can use it for other things, but purely the intention is for security. So, and I just threw up in here how you select, right? Whenever you say select, you're selecting your columns. It's kind of weird that it's backwards here, right? Usually it's, you can actually, in your queries, there's something you can use before select called use, and that's what database you're using. If you're on your whole server, usually it's smart enough to know that the schema.table only exists in one database, and it'll find it for you, but you can specify it. But whenever you log into your server, I mean, these are different ways to log in. You may notice from Gwynn's, right? But same thing on that connection page. Whenever you go to SSMS, right? You say, hey, here's my server. You can optionally specify your database there. You can optionally specify it here, or they're smart enough to pick up on it. And then you say columns first. Then you specify your schema.table. Again, you don't always need to specify your schema because it's smart enough to know what you're talking about. Why add extra steps when it's kind of obvious? But if you had two tables named exactly the same name and they were in two different schemas on the same database on the same server, it would be like, I don't know what you're talking about. You got to tell me. That's a real thing that does happen. And then, hey, where are my rows? What rows are you filtering out? What rows do you want to select, right? So you can hit all of those layers in a database with just a simple query plus your connection. So when it comes to security, we can limit basically any numbers. I mean, server, right? You just say you either have access or you don't. Which databases, which schema, what tables, rows, columns, all of that. So that's kind of the hierarchy of SQL Server is also the security of the SQL Server. We can add limits to that. And again, not that we did it, but you can add, there's like a whole folder in your SQL Server if you're on SSMS called security. Within each database, there's also security one, right? So if you want to do server level security, you have a folder for that. It's usually where you create your users, your logins. Then your database has another security folder if you want to restrict them a little bit further, the schemas and whatnot. So, and that's where you actually can create schemas in that security folder. But that's really all of that security is about. I don't think you're going to get a whole lot of that since I don't think we talked about a lot in class. Again, I'm usually running around fixing technical issues. I don't look at the PowerPoints, but that's pretty much a brief overview of security. I guess any questions before I move on to CRUD? Good. Yeah, not too complicated. Again, that's like really administrative stuff, so I don't think he's gonna go too
I was gonna
hard on
say,
that.
how would he even like quiz you? Like,
Good question. I don't know. Unless he mentions something specific in a PowerPoint or something, I think.
like, is there a possibility of like having multiple choice questions on the midterm?
Yeah, I don't remember there's any multiple choice.
So it'd be just like us writing out and explaining it, I guess.
Yeah, that's most of it. It's kind of like on that homework problems where he asks you kind of an open-ended question and then you write
Oh,
on
okay.
it.
I see what you're saying.
Yeah, that's probably what you maybe more expect. And I think that's where that whole it may take you 2 hours to come in is because you're like, oh,
I was gonna say, because I keep wondering like how many questions can he put on it to make it like 2 hours?
Yeah, I know, right? I think it's being more of those where you can be like, if there's multiple choice, it'd take me 10 seconds. Now you're making me actually write out one SQL server,
Yeah.
So, and I don't think it's going to take you guys 2 hours. But again, if you're at a 2 hour mark, don't freak out. It's not a short test.
Yeah.
It's good to take your time. This is definitely one of those tests where, like, I hear all the time for us, oh, the ones who finish first get like really bad grades. Like, yeah, maybe. This is definitely one of those where you can't really rush through this thing. Take your time and think about it. It's all really simple stuff. It just takes a little time to know exactly what he's asking for, and then how to put that into words. Again, we're not doing anything complex here. CRUD, that's a perfect example. It's nothing complex. You do 4 things in the database, right? I mean, there are 4 things you only can do. You can create something, you can read it, which is just reading as a view, it's a query, just show me the data. You can update something, which, by the way, an update is just a deletion and a creation. I don't mean that as like, oh, conceptually. No, literally what it does is it deletes that, puts it in a temporary table called deleted or delete, and then it puts something new in the same place, and it actually stores that in an info. it puts an insert table, it moves something out into the delete table, it moves that into the insert. This may sound complicated, but we can actually do some fun trickery with that. If we delete a record, you can actually place a trigger on the table and say, hey, if something gets moved into this deleted table, that means someone was trying to update or delete something. Just record that for me. So that's how we can get a log of what's been deleted. Is it does literally, whenever you update it, delete it and put in something that's new. And then of course you can delete it, which is just half of an update creates the other half of the update. Yeah. Or you can read. So kind of silly even to say create or update because it's not anything new.
Is this the one he was talking about where he was saying if you update something, you have to create it first before you delete it in the other place?
Yeah. Yeah. Well, okay. Yes and no. I mean, literally in a single transaction, if we go into SQL and we're like, hey, update, usually there's a set operator, which we didn't talk about. Update, this field to equal this value. It will actually delete whatever is in that field or really move it to another table, a temporary table that you don't see. You can access it, but it's not going to show up. And then it's going to put in that new value. Once it's done with that, then it will erase the old table entirely. It's a temporary table. We didn't talk about temp tables either. They're exactly what they sound like. They're a table that only exists temporarily.
Gotcha.
It's not complicated, is it? And the system creates it like a normal table, and then the only rules that it just automatically deletes it for you. What he's talking about there is literally think about the stuff kind of physically, right? Libraries are often used as an example for database. They're not a great metaphor, but whenever we talk about just the fact that it stores data, it's pretty good. Like if I'm going to move a book from one shelf to another shelf, I don't want to delete the book from that shelf first and then try to go place it in the new one, right? It's you creating copies the whole time. See, this is where libraries are not great metaphors too. Whoops. But you want to make sure that you create a copy of it first, so that way it's in two places, and then you delete one half, it's only in one place instead of delete it first. Now it's in 0 places, and you're screwed. You're out. Data's gone. Where you can't make a copy of nothing. So that's more of a if you're going to move data around, create a copy of it first. Because again, there's no move here, right? We create, read, update, or delete. We don't move anything. Mm-hmm. So if you're going to update something, you're gonna create the new piece first and then delete the old one second. And that's what happens in an update statement. The new stuff gets put in the temporary insert table, old stuff gets moved to the delete table, insert gets moved to the real table, those temp tables are gone. I wish I had a visual to explain that one. So that's more of a, if you're going to move data, don't delete it before you move it, right? It's that simple. You can't move nothing, so don't delete it until you're done. Yeah. Or copy it, really stop saying move, say copy, because that's what you're doing. Indexes, again, that's something that we talked about very briefly in PowerPoints. I don't even think you tested us on it. That's something that I haven't even thought about since this class. Is one of those things that if you're truly making your own database, yeah, indexes kind of help, but it's not too much. Again, an index, just like the back of the book, right, where it says, hey, this word is on this page. It's not much more complicated than that. That's something you have to manually do in a database. And then part of the reason we don't do it is because you need to have a lot of data for it to make sense or to even really do it. And we don't. We have 10 rows here and there. So if you're going to get a question that, it's probably going to be like, I don't know if there's multiple choice, but that would be like a multiple choice question or a quick fill in the blank. I don't know what types of questions if I'm honest, but there's matching. So there's probably, I bet there's a matching. I forgot. There's matching. So there's probably a matching like, hey, index, what's the definition? For that, just look at the PowerPoint. That's all you need to know. That one's not too complicated. What were you going to say, Luke?
Basically, index is just so it just gives you information about where it's located. Is that essentially?
Yeah. Yeah. I mean, it's almost like a quick lookup table.
Isn't it in the index where isn't it typically where the word is, you look up the word or something or a concept and it's go to this?
Yeah. So you can think about that. That is, I mean, if you definition of index, and then if you want a more precise database definition, I mean, it's probably going to be copied straight out of PowerPoint for the matching. I bet that's on the matching. Don't quote me, but
no, yeah.
Update anomalies. I'm not too sure if he's talking about that. Update anomalies. I'm not too sure what he means by update anomalies. I'll have to look at that in the PowerPoints because
Yeah.
that's probably not something weird happens. It's just understanding how an update works. So
yeah.
database modifications, you make changes to your database. How do you create new database? How do you delete a table? How do you add or remove columns, change their properties? I think that was some. How do you make a column a primary key?
What do you mean?
Yeah.
How
So like if I have a table and I'm like, oh, column ID, I need that to be a primary key. It's really simple. You just hit the primary
I was
key
gonna say.
button. Yeah, but just make sure you know that it really, I guess, more than just that can be done.
Okay.
Or in a create table statement, if you're actually going through there, if you guys remember when we did TAL, you already imported scripts, but start with like create table, their name, and then their parentheses, column, data type, column, data type. Do you remember?
Kind of.
Yeah, I mean, we can pull it up real quick. I think I have TAL somewhere. Down here. Is it data science? Groups. TAL. Oh boy, this might launch SSMS. Whoops. Don't do that. Bring it up. So create table, right? This is that database design language.
Yeah.
A table name, open parentheses. I knew it was going to do that. Don't do that. Go away. Create table, open parentheses, table name, the data type, and then right here you can actually specify, hey, it's a primary key.
Okay.
So that's another way you can do it. You can put other constraints on here too. And I think maybe, okay, he didn't put a foreign key. At the end of creating a table, right here, this is the end of that script, that's what semicolon means. You can then say, hey, oh, well, actually, never mind. Oh, no, this is the table. You can then say, hey, add a constraint of this foreign key equals that one. Same thing that we did in class. Okay, referential integrity. That's important. What is referential integrity? Either one of you guys. Oh, there it is there.
Honestly forgot.
That's okay. So that plays right off of that foreign key stuff.
Oh, okay.
So if I have a foreign key, right? So let's see, we have a customers table and we have an orders table. A customer's ID 1 through 10. I have 10 customers. ID starts at 1, last one's 10. And I have an order come in, a new customer. Hey, congrats. Got a new customer. They place an order and their customer ID is number 11, right? So I say in my, you think about it, later in my application on Amazon, they say, hey, place order. I need to do two things, right? I mean, this is a new customer, first time placing an order. So I need to create a new row and customer for them, that customer table, ID 11, here's their name, email, whatever. And then I also need to put in their order. Well, if I go put in their order first, I want to have a foreign key constraint there saying, hey, you cannot put an order in here that does not have a customer, right? My order table needs to have a customer ID column. That makes sense. I need to know what customer placed an order. And I don't want, an order we placed that doesn't have like a customer or any customer at all. We wouldn't want that. So we have to place that customer in the customer table first. Then we can create that order table and say, hey, ID 11. If I do it the other way around, that constraint will say, hey, well, hold on here. There's no ID 11 in the customer table. You haven't done that yet. So spit out an error. Even though I'm going to do the customer part next. That doesn't matter. That's one thing. That's a rule. It's called ACID. It's the acronym. But one of the parts of it is that it only ever does one thing at a time. And it waits until that one thing is complete to then do the next thing. So if you send 2 commands to a SQL server, it's going to do one first, the second after that. It's never going to do both at the same time or anything like that. And if one fails, the whole thing just fails, which is another important part, right? We want something to partially fail. So referential integrity is just that. It's having a foreign key constraint or some type of constraint there. But all we really talk about in this class is foreign key constraints, to where, hey, I can't put in a new record in a table unless those foreign key constraints are satisfied. They have to have a matching record in another table that I already specified that the columns must equal. So it's a way to make sure that we don't get any bad data in our database. I don't want an order without a customer ID. Or
I see what you're saying.
I don't want, trying to think of another example that is in TAL. I don't want an order without a customer attached to it, a real customer, or don't want a customer rep relationship to exist that doesn't have the correct rep ID or something like that. So that stuff is important to maintaining a database that holds correct information, preventing errors. Is just having those foreign constraints in it, and that's the integrity, right? We want to maintain the integrity of our data and our database. So we have those, all this is foreign key constraints. Cascade updates and deletes. I think he said he wanted to go over this last class and we didn't get to it. But do you guys remember talking about that early on in the class?
Like a little.
Okay. So this is something that's not really used in databases at all. But if your data is not perfectly normalized, you may have some values that repeat. So a good example of that is, let's say I had the customers table, they have the customer ID and the customer name. But in my orders table, I have that customer ID, but I also have the customer name next to it. Right now, that's not normalized because the customer name depends on the customer ID, and that's just being the customer's table. But let's just say I have it like that. It's not uncommon to have not perfectly normalized data. They'll try to prevent that as much as possible. So what happens now? Whenever in my customer's table, I go, silly me, I spelled their name wrong. I update their name. Well, now all their orders in the orders table has the wrong name. So cascading, updating, and deleting that, well, this would be cascade update. I would need to say in there, hey, although the name's stored in both tables, they should match. We can put a rule in there saying that, hey, they should match, even though I'm storing the same value multiple times. Make sure that if I update one of them, it goes and finds all the other times that value is stored and updates it as well. So cascading, update, deleting, that's cool, right? If you want to make sure if you're doing that, you might as well make it normalized. But what if I don't? I can say, hey, don't do that. Now next time they place an order, update their name. And then I can go say, hey, here's the orders that whenever your name was misspelled, and here's the orders where it was correct. Sometimes we may want that type of behavior, sometimes we may not. So usually it's better to have just a log of when I updated your name and what it used to be than storing it that way. But again, I can't really come up with a good situation on top of my head. It's probably not something that we'll ever run into as analysts, but someone who's designed application may want that behavior. And same thing deleting. Hey, if I delete this, go actually find all those records and delete it as well. Even with cascading like a waterfall, I just go through it all and make sure everything is matching and happy. Not a huge deal. The fact that he mentioned last class, make sure you just know it. Again, it's in the PowerPoint somewhere, but you don't really have to ever actually exercise that. Okay, anything about general concepts? You good, Luke?
No. Yeah.
Normal forms. So there is a normal forms practice out there that kind of helps you walk through, hey, what are the steps for normalization, right? Normalization is really the end goal, but how can we go through that? So here's this table. Is this table in first normal form? Well, how do we get it there? Oh, right. And then how do we do second normal form? This is a good one to go through on your own time. I realized we're already at 30 minutes in, so spend some time.
Where's this one at?
It's on Canvas like twice, I think, actually.
Oh, okay.
Up there, there we go. Yeah, week 4 and down here in week 2. But to go into practice, I would say practice that first and then reach out to me if you're like, I'm still a little confused.
Gotcha.
But get that one a shot. I think I put that on there. Yeah, so you may also have to describe, and you not just say, hey, look, I took, something into, oh, whoops. I didn't just take a table and transform it into third normal form. Let me describe to you what I did. A little silly, I know.
Does it have the answers on there, or does it? It does.
Well, I would think so. Here, what we got? Third normal form practice.
Okay, I see it.
Yeah, right. So there you go. Let's bring it down. As well as text descriptions. Yeah, it should be also not just, hey, here are the actual steps to which that second slide gives you the steps. Just be able to describe to, hey, all the record IDs to match. I also make sure the names matched and whatnot.
Okay.
Views. Okay, so views. This was a specific question. Views, don't overcomplicate this one at all, right? just pre-compiled code, right? You can think of a view definition as setting a variable, right? For good programmers, variable can equal 2, variable also equals something complex. Well, this time a variable is just equaling code. If we create a view, thought I had an example in here. I don't. If we create a view, oh, I know. Like this one, hey, create view, small customer, or we're just saying, hey, the customer table in the real world, I mean, there won't really be just one customer table. There'll be a whole schema for customers. The customer's name is going to be normalized, then their email is going to be normalized in its own table, their state's going to be in their own table, blah, blah, blah. So we want to put all that together, right? I was working on a project a few months ago for a company's project management software, just to get a list of their projects, basic information, what's their ID, their name, other stuff like that. It was like 20 tables. That kind of sucks to do every time I need to look at a project. And more important than that, I want to make sure that every time I do look at a project, I'm looking at that list that has it all perfectly formatted and filtered to give me exactly the list of projects, right? If I went in there and made a little error again, I wouldn't get that, even if it looked close. So I always want to make sure that whenever we're talking about projects, we're using that table. And if I make a change, same thing, if I go, shoot, I got to make a change to that view definition. What is a view of projects? I want to make sure that whenever I make that change, everyone starts using the new view, so I can always just use the same thing. So all is pre-compiled code. So if I say, hey, select star from small cust, I mean, you can just see that as it will go and replace that from small cust with exactly what I defined the view as. In fact, there probably will be a question. There's a question here on your review. There's a real good chance there's going to be a question on your test that looks just like number 1 here. Write me a view, write me just a basic query that does the same thing or something similar, and then put the 2 together, right? So you can just replace the from small cust with the view definition. There you go. There's no difference there. The only fact is that now every time I go and say, hey, I want to look at the small customer view, I'm always looking at the exact same thing.
Okay.
Real simple. It's just pre-compiled code. It's just a variable. They say, hey, the variable equals this code. And then whenever you execute that, it returns the results. Pre-compiled query. That's all it is. I was gonna for you guys, this isn't on there. This is what I had written. So yeah, I mean, quite literally that additional code would just be added to the query. Just gonna tack it on.
Okay.
Know how to create view blank as, and then that
Just
view
one.
definition. And then if you try to make changes to that, it's gonna be like, well, no, you already created this. You have to say alter. The cheat code is to say create or alter view.
Oh,
Do
okay.
one or the other. And then you can use drop. If you're done with the view, I don't want any more, you can do drop, or you can just, there you go, there, right click, delete view, but that's all it does.
Okay.
I don't know what I meant by that. Yeah, so to simplify the database. Again, even the data we're using this class isn't truly normalized. So for something as simple as a customer's data, it can have 10, 20 tables. So you may want to have a view that says, hey, I get it. That's all normalized. I want a view. I don't care if my view is super normalized. I just want a view of all the customers and their information to use for analytical purposes. This is that OLAP stuff. OLTP is truly normalized 20 tables for a customer. Great for applications. Great if you need to go update something, make sure it cascades update everywhere. It's not true cascade. It's just it always references the newest variable. But for analytical purposes, we don't really super care about normalization. In fact, the process of going in there and creating those views of, hey, let me take the 20 tables and put them all into one customer view, that's called denormalization.
Okay.
Not that you need to know it. But that's where View's strengths really come out, is we're able to simplify what could be 200 tables into 20. And then every time we want to see whatever information we already got a view to look at.
Okay.
Store procedures, views with variables, that's it. They can do some more fun things, right? They can, if we're comfortable with like coding Python R or whatever, it's just a function, really, right? You can just call the function on its own with no parameters. You don't pass it any arguments or variables. Gosh, so many names for the same thing. And if you'll just execute it. So like there's some store procedures like, hey, go to this thing to my database. You don't need any variables to do it. I just need you to go run some commands and it can do that. Or you can pass it some parameters and say, well, hey, I want this to be dynamic. I want to, it's kind of like saying, hey, I like my view. I like this view down here. Give me the customer's number, name, all that stuff for where their credit limits, less than 10,000. But I also need it for 5 and 7 and really any number. So do I create 20 different views for all the possible different numbers I need? Or can I make a stored procedure where instead of saying 10, I just say, add, credit. Like that @ sign is how you initialize a variable in SQL. And then whenever I call this view, I just specify the number. That way, if I come in here and say, hey, I also really want, customer brands ID, like type like that. Now, every time I call that, I don't have to recreate 20 different views for all the different possible credit limits. Now it just works. All nice and happy. So a stored procedure is nothing more than a view with, nothing more than a view with some variable or parameters or whatever your favorite name for whatever that stuff is. Great for automation too.
Okay.
Sometimes you can have a stored procedure run every night. Once a night, my stored procedure is going to go in there. It's going to grab some data and throw it somewhere else. Or once a night, I'm going to do a real quick check. Stored procedure, go run through this database and check that everything lines up correctly. That's what you can do. I'm trying to think of where I've used stored procedures before, because I know I've written quite a few of them. But I've really moved away from stored procedures lately. Man, what's one of them? I'll think of it. Maybe if we meet again on Monday, I'll come more prepared with examples. Now, triggers are different, right? You can really think of a trigger as a stored procedure, but it's just tied to a table. But again, like I said here, I don't think you guys will have to write anything. We didn't have to. So whenever there's an event, where an event is creating, reading, updating, and deleting on a table, it will just execute that code. It's tied to that table, so you can't be like, hey, whenever I create, read, update something on the whole database, it's not going to run. But for a specific table, you can. And again, that was just that update where if we have a calculated column that we want to store physically, what I mean by that is if we have a calculated column where I say, hey, here's the balance the customer owes, here's how many payments they have, and here's what they owe. Well, balance minus payments equals what they owe, right? That column, if I want to store that as a solid number, not like in Excel where that column equals a formula, but I want to store it as the number itself, then I can use a trigger. Say, hey, whenever there's an update, go in there and go make sure that all equals. Practicality of that is pretty small. I think it's a good way to have an example of what a trigger can do in the real world. Why not just have a view that has that calculation done for you? So you don't have to waste precious processing time doing that every time something gets updated. You can just only have that execute whenever you need it. But whenever it comes to what practicality there is for triggers, that really gets into database administrative stuff. If I really want some types of checks to be done, hey, I have a new row entered and I can't use a referential integrity or a foreign key constraint to check something. So I'll have a trigger check in and spit something out or produce an error if it doesn't work. The reason we don't talk about that is because, well, it sounds as complicated as I'm making it sound. It doesn't really make sense for us because we're analysts. We're trying to understand application databases, those OLTP stuff, but we're not going to go build OLTP. We're going to go build OLAP, analytical processing databases, but they're built on top of OLTP, so you got to know. So that's why sometimes we're just going to say, hey, have a general understanding of this because you may see it. If you're going in there and you're creating those views where you're mixing 20 tables to produce one customer table, and you're like, this is weird. It's producing some strange data that I'm not used to or not, I unexpected. It could be because of triggers. There's no triggers to do weird things like that. Right. Oh, I did put on here. Read does not actually fire a trigger. So you're just looking at data. There's no point in having it fired. Blah, blah, blah. Yeah, auditing. If you can't use foreign keys to make sure that a new record is correct. Like if I want to have, you can have a customer with a credit limit over $100,000. That just in our world doesn't exist, I can use a trigger instead of creating a whole nother table and creating reference. Nasty. Just create a trigger and say, hey, if this record comes in, I can't use a form key for that. So just have a trigger spit out an issue. And I think they can actually just stop it from materializing the database. Also security or logging. Hey, someone came in here and they updated something. That's that whole, well, an update's really just taking the data, moving it to a temporary table, taking new data from the temporary table and you can track all that. You don't need to worry about that today, but that's where that comes in, same with automation. So, and when we're talking about views, just know the basics, right, of how to create one. You can't do it on the test, right? But you could, while practicing, actually go into SQL and write out a view. I'm pretty sure most of all this is based on TAL. If not, you can translate it to the equivalent TAL code. Just practice, hey, how do I write a view from in TAL? Try to match this. Does it execute and work? Well, then you know you got the right code. And then that's how you have to practice is just, hey, create small test as the same stuff to make sure you didn't actually put where before from or something like that. On the actual test, you won't be able to test that, but at least you'll be able to know for sure while doing this review that, hey, this code executes and produces the result that I want. You know, whenever we talk about where, so it doesn't have to be equal to a number, it can be equal to another column. That's cool.
For that one, I had a question. So when he was doing it, and he was like dragging it or whatever, it had like brackets. Do the brackets matter?
No, so brackets don't. You know, SQL's gone pretty smart over the years. So it kind of knows, hey, after where I'm expecting a column. So we can put balance there. But those brackets are kind of a, what's it called? Like you go bowling and the guardrails come up to stop the ball from falling out. Well, the ball is like the name for the column. So putting those brackets in there, like you had a space in a column, don't put spaces in your column. That sucks. But let's say you did, or the database that you're working with, some idiot did, you put brackets around it. It says, hey, everything within these brackets is the column's name. And it helps with readability a bit.
Okay, so it's not like anything that you have to do necessarily.
No. So whenever he's dragging and dropping from SQL, just always going to put those brackets to make sure. There's some other like special characters you may not want to show up because they may mean something different whenever it's not in a bracket. Or I think reserved words are the same way. So like if I say select, if I had a column name select, and I said select, it's going to be like, I can't, what are you talking about? That makes no sense to me. If I say select in brackets, the column name select, and I go, oh.
That makes sense.
You know, so those types of reserved words, which I mean, I copied this from SQL, right? They show up in blue and whatnot. You got to make sure those are in brackets if you're going to use them outside of what they mean to SQL.
Yeah. Okay.
Good. Ultimate SQL creator turns the same results. You can simply apply 2 queries to run as one result here. Oh, yeah. So like if I want to combine, hey, I want credit limits equal to this. You know, where the credit limit is under 10,000 or equal to, or the balance is more than their credit limit, I can just.
So the only thing you changed, okay.
I just put the two conditions the same, and I guess I simplified the select part. Yeah, I didn't select as many columns, but select more columns whenever you do it, I suppose. So yeah, whenever you do multiple where conditions, same thing here. Same thing like in Python or R, whenever you guys were writing those filter conditions, you gotta, you know, even if I had credit limit more than equal to 10,000, but I also wanted it on the flip side, hey, greater than 500, I'll have to rewrite this whole thing here again, right? And you know, for 500, there you go. I can't be like, hey, credit limit equals this, and that. It's gonna be like, and what? There's a no, right? So you have to be real specific.
Okay.
That's something I know someone's gonna do on the test, and the professor are gonna laugh at it. But you gotta be real specific with it. That's not gonna fly. You gotta go back to that.
Okay.
Yes, that's just how you combine those 2 queries. This is very similar. I must skip over this. You just do it again, and look at that. I even said no inner joins, and there's clearly one here. But you shouldn't need to do an inner join here. You should be able to get away with a left join. Again, really all you need to know is left joins, because pretty much all you'll ever do is a left join. Same thing, pretty much, put them together. Try that on your own and reach out again, we can go over it.
Okay.
Oh, look at this, data anomalies. So in this table, we have all this fun stuff. Okay, what are our dependencies, right? And easy even over here, here's how we write dependencies, right? Felix to field Y. So, and I just showed you the answers, but how would we determine, I'll even show you the answers. How would we determine that department name depends on department ID? If we look
Just
at
because
this,
those two things are connected, right?
yeah, how do we know they're connected though?
Or is that what you were talking about when, oh no, never mind. That's not the same thing.
You know, there are some kind of helpful hints here whenever we say, hey, department ID and department name. But that doesn't necessarily mean that they're dependent on each other, but we can see here is that for each department ID, there is only one unique value associated with it, right? So community services wouldn't show up with a different department ID, and each department ID wouldn't show up with any other department name besides this one. So we can clearly say, hey, this depends on this, because every time I see this, I see the exact same value here, and I don't see this value anywhere else or anything else besides this and this together. They're best friends. They do not cheat on each other. Same thing over here. It's not as obvious, right? Each time this is all different IDs, but I don't see postage show up again over here. And if I do see meals and entertainment show up again, it's with the same ID.
Yeah.
So we can clearly see that, yeah, these two are dependent on each other. Now, what if for some reason on here, you know, this said meals and entertainments, then we could say, well, these don't depend on each other. They're very close, but this same ID has a different value. So there's something else that we don't see that account name is dependent on, but it's not account ID because we have two of the same account IDs with two different names. And we can clearly see that, well, here's another question. How do we know amount's not dependent on account ID?
Because the 14s are different.
Yeah, 14s are still different, right?
I was gonna say, yeah.
Now, and what if they just so happened? You know, if for some reason this won't show up on your test, I would be incredibly shocked. But if we saw this in the real world, we were looking around and we're like, hey, I'm noticing that for each unique account ID, there's a unique amount. And whenever I see an account ID, I always see the same amount. Could that be a coincidence? Sure. This is where some of that business knowledge comes in, right? An engineering student would just go, yeah, they're clearly dependent. The business also would say, I don't know why amount would be dependent on account ID. It doesn't make sense. And you need to dig in a little further, talk to some other people, or review the code of how this view is built, and goes, truly, or is this just a weird coincidence? So not, again, that's going to show up on a test, but if it feels fishy in the real world, it's because it probably is. So we can also use a little bit of just common sense in here and go, well, I bet account names dependent on account ID. But we know for sure because we see it in that way.
Yeah.
And then again, we just listed this way, department ID. Or I know it almost goes this way, account names depend on department ID, but with department ID is what we're saying here. With department ID, we can get the department name. Oh, any questions? Okay, let's see here. Oh, this is, okay, don't look at that too closely. This is that question you were asking, Luke. So give an example of the following update anomalies used in table 1. Or is that my answer? Okay, just give me an example of how we could have an update or inconsistent data anomaly in table 1. There's no one answer, but this is going to be part of that test too. There's no one answer for this, but there are many right ones. So if I go in here and I update something, how can it
Wouldn't it be
not
like,
go right?
would it be the same thing as like if you did meals and entertainments, wouldn't you have to also update the other meals and entertainment to like with the extra S or
Right,
whatever?
right. And we can clearly see this is not normalized data, right? So if I went in there and I did that meals and entertainment, so it'd be like, whoa, that's not good. Let me charge my computer real quickly. Look, I mean, there's more than one. Can you think of any?
Like if you change the department ID there, the department name, you would have to update the department name for all of them. Where am I at right now?
Yeah, right. So like, and we could achieve that with a cascading update in this not normalized table, or you just normalize it. Oh, I was showing you this. Okay, yeah, exactly. Or the other way around, we can just change the department name to be. I said ComServe, right? So if we abbreviated it, and then we say, hey, well, then we would have other department names assigned to the same ID, even though I meant the same thing. Their literal values are different, and that would be inconsistent. So that's that inconsistent from an update, if you will. Yeah, like I say there. Deletion. How could we have an anomaly, something that we don't want with deletion? You'll probably be asked these questions with not normalized data, because normalizing it kind of solves a lot of these anomalies. So let me show you the table again. So how can I have a deletion anomaly?
Well, okay, question. So the reason why it's not normalized, is it because these are all repeating? Like there's multiple, like community service, there's multiple media relations, and there's not just like one of them? Like what makes
Yeah.
it not all normalized?
Well, whenever something is normalized, you wouldn't have exactly that. I wouldn't want to store in a table any dependencies, basically.
Mhm.
So department name is dependent on department ID. I wouldn't want to store those in a table where department ID is not the primary key,
Mhm.
because then I would have this value stored more than once.
Correct.
Like think about a CSV file. This value would be stored more than once. So if I could come in here and change something without changing it somewhere else.
Mhm.
So it's not normalized because, and you really say it's not normalized because we can have those update anomalies.
Okay.
Because we could have update, because we have deletion and insert anomalies, it's not normalized.
Okay. So for the deletion one, would you just like, this could be so wrong, but like you could like delete the deletion anomaly would be like deleting the media relations one at the bottom, and that would like mess it up, because I actually have no idea. I don't know.
Yeah, I mean, fair enough, right? If I delete row 6, what happens to account 14? Does account 14 go away?
I mean, you would delete it, but it shouldn't go away, right?
We wouldn't want it to, because ideally I would store count in its own table. But this is not normalized data.
Okay, I see what you're saying. So since it's not normalized, that's why you have all the issues.
Oh yeah.
Okay.
We're like, oh, but yeah, it's not normalized, man. If I come in here and I update a name, I'm gonna get different things. I don't want that. It's not normalized. If I come in here, what did I say? If I delete row, then yeah, there we go. Exactly the same thing with row 5. Then account ID number, was it? I think I meant account ID number 7. The account ID in row number 5 would be permanently removed. If I delete any of these rows, poof, there goes that data that was associated with it.
No, that makes sense.
I might not want that, right?
Okay.
Maybe I say, look, account 14 is gone. Happy birthday, business. I'm going to take care of account 14 for you. I don't also want to delete these other rows here. So
yeah.
So basically,
yeah.
So basically, what you're saying is like if he was wanting us to normalize it, we'd have one table that just had account IDs with the account name, and then maybe a separate table that connected it that had like an order number or order line, like he would say in class, and it would have that account number with and that's where you would get the amounts, because maybe the amounts would be connected to a different table as well. That was just the order table, not an order line.
Yeah, well, I would have a department table with the primary key of department ID and department name, and it would only have 2 rows, because it would have CS community service and MR media relations. And then I have account, same thing here. It only have 5 rows because we have 2 14s. And then I would have some, I said bridge table to some other students, bridge table or some side of, right? If I create a many-to-many relation between the department and account table, that wouldn't go quite well. So I would have this bridge table here where I say, hey, for maybe these are transactions. That's what it looks like to me, like literal dollar amount transactions. Hey, transaction number 1 had department ID CS, account 25, and this amount.
So would you have to make 3 different tables for this one?
Yeah.
Okay.
Yeah. And it, a lot of people, if they were asked to normalize this, a lot of students who even have passed this class would say 2. So be like, well, I see 2 dependencies there. I see department name depends on department ID. That's the department table. I see account name depends on account ID. That's the account table, and that's it. They forget about the whole rest of it. Why does this table even exist? Well, because we've got to log all these different amounts.
So wouldn't you have the department name and account name together to get the amount?
In that table? Yeah. Where we're together.
Technically, department ID and account ID is what I meant,
Yeah,
right?
department ID and account ID together would be
Yeah.
the primary key, which we don't say this in this class, but it's called a composite key. We
Okay.
have more than one field being the unique identifier, or maybe I make things simple, just place on a transaction ID, which you can do something in SQL where you say, hey, just give every row its own number. And that's sometimes helpful.
So is this where he was saying like, oh, I'm sorry.
No, yeah, but
Is this where he was saying like on like certain tables like this, to get this result, you could have a key be a primary key and a foreign key at the same time?
right. So yeah, it would be.
Because these would be technically like foreign keys, right? Because they'd be going to the other tables. That like, okay, that makes sense.
Yeah, so department ID and account ID together are one primary key.
To get the amount, right?
Individually, they're foreign keys.
Correct. Okay.
I wouldn't want to, there's, we can just infer that from this. These are charges. This account charges this amount to this account. This department, charge this much to this account. I wouldn't want to have a charge in here that isn't to a department. Gosh, that would be really evil, wouldn't it? If I was a smart tech guy, I would go in there and just be like, ooh, let's put a charge in there for $10,000. It's to no department, so it won't show up on any department's budgeting or financials or anything like that. No one's going to get charged for it, and I'll put that on some random account, and I'll just take the money out. And I can go, well, clearly there was a charge for $10,000. Gosh, who knows where it went? It looks like we had a weird error in there. No department got charged for it, so no one knew it even happened. This is how embezzling happens.
Okay.
How do we solve embezzling problems? Make really good databases. So that's why we would have that bridge table between and have those foreign key constraints. Hey, it'll go, can't charge me, can't take $10,000 out until you also have a department ID in there. And then somebody's going to know about it. And you're going to get fired. That's a good example of where that comes in. Yeah, so I'm saying here you can delete row 1 and then no Post-its account anymore. Whoopsies, how'd that happen? Some portion of the primary key being no. Yeah, I mean, is it the same thing?
Was this what you were talking about? The one that like you can't add something, like you can add like something in the I forgot what it was called.
This is literally what I was just talking about. Foreign key, like I wouldn't want to put in a new row in there, and I did it the other way around here. Hey, we insert row 7 into that table. I have a department ID, but I don't have an account ID. It would say, hey, these 2 need to be foreign keys, right? But that's in a normalized database, right? In a normalized database, I can have that foreign key constraint because I'll have 3 tables, not 1. But in here, what's stopping me from putting in row 7?
Was this the referential integrity thing?
Same thing.
That's what I was talking about.
Yeah,
Okay, I
same
couldn't
thing.
think of the name for a minute.
Gosh, do we have enough names for everything yet? Guys, it's all the same stuff. You want to get real technical? I can boil down this entire thing into like one concept, but again, right? Everything functions on bits, right? But it's a lot saying, right? It's like in this situation, this table right now, I could. There's no way, there's no referential integrity, there's no foreign keys because I only have one table. I can insert row 7, put in no department, no account, put in some amount. That's fine. The only way it could stop me from doing that is if I placed a trigger on that table that said all those things. It's better to have a referential integrity, more efficient. So yeah, really these things are all kind of the same thing. You can, this table in this current format, not normalized, we can kind of do whatever we want. Whenever we normalize it and we place in those constraints, suddenly we can update something that doesn't match fully, can delete something that will result in something being truly permanently deleted. We only get to delete what we want to delete. And we can't go insert new rows in that don't have, don't match correctly. stop embezzlers. And yeah, same thing. You can just add an account without a department. We don't want that. We want both an account and a department in there. And maybe you can say, I want an amount, you know, that you would do with a trigger. Am I going to create an amount table with every possible amount and say, well, it has to be in that table? That'd be a nightmare. How many possible amounts are there? What kind of infinite? Goodness. So I can just say, hey, amount has to be not 0.
Okay.
Good enough. That's a trigger. And we can solve anomalies with that. So does that make sense? So anomalies are really reasons why we want to normalize the database.
Yeah.
Because as a table as is right here, we can do a lot of weird stuff with it that we wouldn't actually want. We get, whenever some business user goes in and tries to do a report, they're gonna be like, why are there 2 department names for the same department ID? We'll be like, well, because we didn't normalize our database, you know? These are really reasons why we want to normalize. Because we can solve each one of those saying, well, we'll just normalize it. It works. That's the only reason why you study these, because now you know why we do it. Because it can be a little frustrating sometimes. You want to create a customer table out of 20 tables. Goodness. Any more questions about anomalies? You good, Luke?
Yeah.
Wonderful. Stored procedures. They're just views with variables. Right.
And the at is what starts the variable or whatever?
Yeah, so the structure is a little bit different here because we have to have these variables. We want to specify them in a certain part of the code, right? If we're, you guys do Python yet, or is that? Okay. So if we, well, okay, is anyone here computer science and did Java? Okay. I don't know if they explained it well in Python, but they did it well in Java. You initialize a variable and then you set it. I'm not, okay, I'm about to like talk for an hour on that. Anyways, we want to say, hey, create this variable with this data type.
Okay, that's where I got like confused. What does the 8 and the 2 have anything to do with it?
Whenever we're talking about a decimal, so we want to be real specific. What happens here is in the memory in our computer, it's going to reserve space.
Okay.
It's going to say, hey, give me enough bits to store a value with 8 numbers and 2 decimals.
Got it.
And it's even if I don't set that value to anything, it's going to save that space for me to use. So that's why, you know, whenever we were importing data, he was like, if I know this column only ever has 8 characters, I'm not going to put 50 characters in there. I'm only going to put 8. Because this database wants to store data super efficiently, right? It's not like an Excel workbook. God, those take forever to load, right? Because we can put anything we want anywhere. So as to say, hey, give me like the max amount of space you can put in anything for every single cell. That takes up a lot of memory. Excel files can get very big very quickly. I want to store millions of rows, billions of rows. I'm going to go way beyond an Excel file's limit on the amount of data I can store, and I want to use less space. And I can do that by saying, hey, instead of reserving for every single value the max amount that you can, or Excel does it dynamically, but the max amount that you can, just give me 8. That's all I need. That's real tiny. That's next to nothing on your computer's memory or storage. And in the business world, that's everything. That's money. It's money, that's performance. That's a huge cost saving whenever you have billions of rows.
And then did you just say equals null so that it wouldn't?
By default. So this is important. So I don't have to put this here. I can just leave it as is. But if I go and try to execute this procedure without specifying whatever these equal to, I'll go, well, they're equal to, like, not null. Remember, because null is still something. Null is the app. Okay, null is confusing, right? Null is something. But if I say literally nothing, it's going to go, I don't know what to do with literally nothing. Null just means, hey, there isn't anything here, which sounds weird, right? And again, that gets into computer science. But null's not literally nothing. It means, hey, nothing's here. Where literally nothing means, oh, I have no clue what to do with that. You know?
Yeah.
So what I'm doing here is assigning the default value. I'm like, hey, if I don't specify this, it's equal to null. So that way, you know, in this code still wouldn't execute by that, but I can also I can put in some formula there. The start balance equals the minimum balance, the max, or end balance equals the maximum balance. Give me all of them. Give me where the balance is between all of them. So give me everything if I don't specify, and then I can limit it further. So it doesn't have to just be null. It can be a little bit of a formula there, but you don't need to know that for this. So the structure is a little bit different, right? We say, hey, instead of create view, create procedure. You can also say, not that you really care, you can also say pre-proc shorthand, if you will. How many people really are writing that many procedures? They need to use shorthand, I don't know, but you can. And then its name, right? So create view in its name, create procedure in its name. However, you say create view as. But before we specify what we want that view to be, we are going to give it some variables. Or say, hey, in whatever comes after the word as, these variables are going to exist. And I'm telling you to go ahead and create them now. Go ahead and reserve that space in here now. And then I'm going to use it in the code. And again, that 8 means I can have 8 numbers before the decimal point, and 2 is I can have 2 numbers after the decimal point. And then comes that as, super important, right? As is like an equal sign. Whenever we create a variable, my favorite number equals 2, equals is as, or the arrow in R, if you do that. Begin and end, don't worry too much about this. It's just saying, hey, begin here, end here. Sounds a little silly, but you can have multiple begin ends if you really want. Don't worry about it for this test. Just know that there's a beginning and end. Who cares why? There just is.
Okay.
And then look at that. It's the same code pretty much as before. And yeah, you can say where. I think between is a real word that you can use. And where balance is greater than starter and balance, less than end or equal to on both of those. I think you can use between as a real word.
So could you do that, or could you do balance? And would you do like parentheses at starter is greater than or equal to something?
I guess I'm trying to remember if between is a real thing or not. We want to say like great equal to at start. Wow, nice try. And the worst the other way around.
Okay, got it.
Man, we're just getting good with that. And so close, but okay.
Got it.
That's the safe answer.
Okay.
I'm totally blanking on if between is real or not. I might have just written that in there to be quick. So let's just, be safe.
Okay. Makes sense. Is this one the same one? Is this basically the exact same thing?
Yeah, I just did dates. And I didn't read it all here. It's just like, and there's some joining of tables. Hey, here's that whole order line dot order date. Where have you seen that before? Wasn't that right over here? I said table dot column right there. Order line dot date. So I'm just picking out the piece that I need to specify. Because order date may appear in more than one table, right? That column name. So go, well, what column are you even talking about? You're being ambiguous is the error it pushes out. So I specify, hey, in the order line table, give me the order line date. And if you're real good, you're gonna go period. Isn't that Python? Yeah, I could also just do this. We're cool enough to accept either of those. Actually, Python for them either, but you don't have to do dot. You can also do the brackets or whatever you want. So here we're also putting an aggregator up here, right? I'm not saying, hey, don't just give it to me. Aggregate it.
Okay.
What happens whenever we do that though? We have to do something else to our code. Super important.
You have to end it.
Where? What do you do?
Like there's a begin, so you gotta put end.
Oh no, I meant what happens whenever we do. Luke, do you know whenever we do an aggregator? What else do we have to add? Yeah, group by. I flashed it a second ago. I didn't mean to by that. All right, some by what? Some by what measure? You have to specify it. So don't forget, if you're going to do something like that, put an aggregator in your code. You gotta have a group by, and your group by has to do whatever else is out there.
Okay.
Is this code still valid?
Would you group by again?
You would need to add it here.
And just comma.
And down here as well, item. So category. All right, because then we go, okay, I get it. I'm grouping by category. What about subcategory? Where does that fit into this puzzle? What am I supposed to do with subcategory? Because remember, we're just literally have the values of all the subcategories stored for every single row, and it goes, how am I supposed to squish that down to give you a summation? I'm not able to do it unless you tell me, hey, also group by these values as well. For today, just remember you got to do that. We'll find another day to go a little more into what happens whenever we do group by and why would I need to specify both the item category and subcategory. Don't specify this because that's what you're summing by.
Would it have been wrong
Oh,
if you
and
just
here's
put
that.
select some category in parentheses category? Would have been wrong with the way he worded it?
If I did what?
Would it be wrong if you just put select some and then in parentheses category with the way he worded it?
If this said category here?
Yeah, like if you just put select some then category.
Oh. Wait, all right. Some category? Like
Yeah,
that?
like if you didn't have all the other things with it as well. With the way he
Well,
worded the question, would he still allow that, or would you need to go into that detail as well?
so it wants you to return the number of items sold by category. This would just, well, this probably wouldn't even really execute because category is probably not a number. And if it does execute, it's just going to
Oh,
be
gotcha.
the
Gotcha.
number value of the text of category, which would be really weird and meaningless.
Gotcha.
So it's going to go the column category. You got to be real specific and say, no, the number ordered, which will just
Gotcha.
give you the count, add up all the items that were ordered by category. I don't think subcategory is a real thing. And then group by category. So that whole by is a group by. Pretty easy.
Okay.
And again, here I'm just specifying, because remember, I'm going to do from orders to get from orders to get to items to get the category, order line to get the number ordered. We have to go through a few different tables because in this situation, we're a normalized database. I didn't write all that out because I was probably too lazy last year, but we would have to specify the table name as well, so that way it knows which column in case these columns show up more than once.
Okay.
But this is an important part here. Okay, so I was wrong. Between is a real word. You can't say between and then your variables, begin date, end date, where this date is in there.
Okay, so if there's not gonna be inner joins, why are there so many inner joins?
So ignore this interjoin stuff. It's the same as that.
Yeah.
Yeah, most of the time, inner and left are going to produce the same result. Here's a question. I'm saying, hey, where order date is between our variable dates. Great. Why is order date not in my select statement?
Mm-hmm.
Yeah, it probably needs to be, right?
Yes.
Not quite. So this select part really acts more as a filter for our columns. Just like where is a filter for our rows, select's more of a filter for our columns, or subsetting for Python, if you will. Whenever I run this, it'll actually produce the full thing. It'll create, it'll do all of this. It'll start off with all the columns from all the tables as they're joined, and then it'll go say, hey, what did he say in select? Only give me these. So it will already create it with the order date there, filtered. After that, once it's done, it's filtered, it's done the grouping, it's done the summation, it's joined all the tables. Then it'll say, okay, but actually only show this guy or gal the columns they wanted.
Okay.
So we don't have to specify, if we're going to do a where or our join columns, all that stuff, it doesn't actually have to show up in our select. Select, although we specify at the beginning of the query, it almost happens at the end, where we say, hey, only show me 2 columns, total 1 item category. So again, you're more than welcome, and it's always a good idea to throw that in there as well, just to give yourself a little visual peace of mind to say, okay, I can see the order date, I can see that they are between my 2 parameters, but you don't have to have it in there. Okay, that's it. Any other question about stored procedures?
I don't
No.
think so.
Yeah. The important thing there is, hey, remember that the wording, I mean, you don't have to worry too much about the inner part here. This is just the body, if you will. But hey, create procedure, the name, specify your parameters with their data type. If you don't set them equal to anything up there, then you have to specify them whenever you run it. We haven't even gotten into executing that. I think he showed you it. I don't think you'll need to know that if you care. Execute and its name. I don't have to say procedure because anything you execute is going to be a procedure. So it already knows that. And then if you want to specify variables. But if I just ran that, it'd be like, oh no, you have to tell me what these equal. But if I went in here, I said, hey, they equal null. Then I'll be like, okay, cool. I'm going to use null or whatever. If I want to be like, hey, the begin date I know is going to be that. And I say, hey, this is just the max order date. I probably have to do a whole like max order date or something like that. But then it'll execute that, find me the max order date, and then that will be the value there or whatever. But yeah, you can also just say that. Or if you don't specify it, you should specify whenever you execute it. And it's good. And then body is just whatever query you want in there, no different than the very first question. We were like, give me a query. It could be this query if I wanted to.
Okay.
I can create a procedure. I don't know why I would. But I can create a procedure. That's this. Has no parameters. And I say execute this procedure, and it runs it exactly the same as a view would. No different.
Mm-hmm.
If I wanted to add to that, then I got to make sure it's a procedure with parameters in it.
Okay. That makes sense.
This is really just a really dumbed down version of any other high level or high language programming level language shit, if I can talk.
So basically, if we go over, or these as in-depth as the questions are gonna get, besides like the,
Again, I don't know. I don't have my heated class on at the end, so I can't look.
Yeah.
And I don't know what the test will look like. I don't help them design it at all. Yeah, there'll be a few more conceptual questions that I would say would be the PowerPoints for. I don't remember. This test is really a mental test. It's really easy to sit there and start getting freaked out. If that happens, just take a step back. There are two things you should know. One, there's usually more than one right answer. A lot of these questions are going to be open-ended. I think there's some, if I remember correctly, some matching. So those are pretty, here's the, what is an index? Go find the one sentence that describes it and draw the line. That's probably going to be on there. Maybe if you fill in the blank, those are going to be pretty straightforward, like any other test, but there'll be plenty of exactly like, any of these other questions there. Hey, create a store procedure, and there'll be a box underneath it where you have to write out create procedure, blah, blah, blah. You write out your SQL code. That can get a little intimidating because it's like, well, there isn't necessarily one correct answer. There's a few different ways, right? Just like any time we program anything anywhere, there's more than one way to do it. More than one way to cook an egg. So as long as you step back from that and you look at your code and you're like, this to me makes sense that it would answer this question, that's okay. And the second thing you should know is you can contest. When the next class, when he hands it back to you, if you see he took out points for that, I wanted this, you can go up to him and be like, I know you wanted this, and I get it. Your way may be the better way, but my code still answered the question. Like this still, or help me understand that this didn't satisfy it. And I remember having to do that a few times, being like, all right, fine, I'll give you back the points. You're right. It's not the most efficient, but it still does the same thing. Produces the same result. So know that might give you a little peace of mind while taking a test. If you're like, I don't know if this is perfectly correct. It doesn't mean perfectly correct. Even if you get it back and get a few points off, you can check in and be like, well, is it truly just wrong, or is it just not exactly the answer he's looking for? He's probably working off of an answer key whenever he has to grade so many of them. Late at night, he's not going to think too hard about what you literally wrote and go, this doesn't match. And then he does the same thing though. So hopefully he'll get better about this year. And the only thing is, don't be intimidated. You're going to look at that thing. It's a really, I remember it was so weirdly formatted. It was like boxes all over the place. It looks like the guy made it in Excel and then printed it on like paper, which doesn't work well for, I don't know. Don't get intimidated by its look. Okay, it's not much more different than any other test you've taken, so. Just study your material, you'll be
Okay.
fine. And he wasn't lying. Most people make a 95 on this.
On the exam?
On the midterm, most people make a 95.
What?
I was.
Pretty sure I said that at last class. Most people walk with 95. If you like, you have to do bad. You have to really not been attending class and not watch any videos to do that. Most people make a 95.
What?
But study. I think most people
Oh
make
yeah.
95. They freak out and they go study so much and they come in there and they're like, oh, I know that. Oh yeah, I know this. Oh, I know how to write a stored procedure. Here you go. None of this is really that complicated. And I don't mean to sound like an asshole whenever I say that. I mean, like, if you approach it from, this sounds scary, this sounds complicated, but what does it really mean? And you'll learn quickly that anything in, especially the data world, holy crap. I don't know why marketing people like the data analytics world. Like, guys, everything we're learned here, it's been the same since the 80s. Nothing's changed. They just slap on a new label every year. Look, guys, I mean, as you guys see right now, everything AI, it's AI, and like, it's not. Literally not. Everything's AI, right? But it's the same stuff it was 10 years ago. They just changed the name and poof, now they're charging you more for it. So
Okay.
it's really, I'd again, approach just from, hey, this is supposed to be simple. So, because there are things like that are complicated, right? Go do calculus and you're going, okay, it might get a little complicated. This pretty simple, right? So approach that with that mindset, and I found that helps students, and it helped me too to go, okay, this is supposed to be simple, then what does it mean very basically? You're good with it.
Okay.
Yeah.
Okay, sounds good.
Yeah, so give that a shot and give the normal forms. These just kind of suck to go through. You only ever need to know it for this test, maybe the final if it's cumulative, I can't remember. And then throw it away. Don't ever care about it. No one ever talks about normal forms. There's another class, 4350 BI and big data is like the continuation of this class. The professor's like, here's the normal forms, I have to show you in slides, skip, never look at that again, No one ever cares. Normalization, right, the result of normal forms, we like that, not the forms themselves.
Okay.
They suck, no one cares about them. Get an A on your test and then don't ever think about them again. Don't tell professors about that. Although he would probably.
You think he'll tell us or ask us what's the difference between like first form, second form, and third form?
Kind of. He'll definitely have you go through it. Oh wait,
Okay.
because the PowerPoint. He'll give you, just it'll be a lot like that practice. Here's a table, first
Like
put it like,
homework that we did.
yeah, it will be like, man, okay, let me bring it back up super quick because I know it's right here. It will be like, hey, here's this table, and then you'll fill in, right, the stuff here to put it in first normal form, right? So with these blanks, you would come in here and write in that and this and those two.
Mm-hmm.
And then
Gotcha.
he may ask you, say, what, describe what you did. Well, I put in here, I went here and I saw that
That's
the
fine.
first row
I can do that.
had a value, the second row had no value. And so by first normal forms rules, whatever's in the first row should be in the next empty rows until we hit a new value. And then we do, yeah. So, same thing was, second normal form and third normal form, you might need to explain a little bit. These are the same tables. Oh, there we go. Identifying it. There we go.
Mhm.
A little bit better. Or wait, did I skip second normal form? Okay. Okay, maybe this one didn't.
First normal form is just like the blanks, like nothing can be null, right? Or like
Yeah, well, nothing. Well, we can't say nothing can be null, but there shouldn't be any blank IDs or whatever. Yeah, good enough for it.
And then what's second normal form? Like what's
Yeah, and this one it's probably more the question is what is the relationship, what are your dependencies and all that.
Okay.
But these are the same thing. What oh, I see. Student name visor ID was solution on the menu.
so the second
So,
normal
okay, here
form
we go,
not
yeah.
having many to many relationships?
Yeah, and so it's split up into tables, right? I have student, right? Student ID, student name, date of birth, GPA, all that depends on my student ID. So there's your student table.
Mhm.
My advisor name depends on advisor ID. So there's my advisor table. Student advisor table, bring the two together. And then are they multiple IDs or descriptions? Yeah, here's your multiple names and IDs and
Mhm,
names. Here's my foreign keys that I would have in there.
mhm.
It's really getting to that normalizations point, right? And what does this one say? What's the primary key? Where are the IDs and descriptions? Again, this is not in form or the possible anomalies.
Oh, I
Yeah,
think
I'd
there's
say-
something multiple.
Yeah. I'm trying to think of ways to stay my list by anomalies here. I'll take a look at this too. I didn't write anything down for me. But I would say look at the PowerPoint of our normal forms first and then do this
Okay.
practice. This format's pretty weird, right? I was thinking it'd be more questions and then clear answers, which it kind of seems to be going that way, but it's also confusing.
Mhm.
So take a look at this. Also see, I think there's a resource out there for going over normal forms that someone pointed out to me.
Okay,
I look at that's like an online practice. So
okay,
yeah, they suck and just push through them and then forget about them.
okay, that's good.
Yeah, I'll try to find something, and then hopefully if I do something Monday, at the very least Monday, I will try to send out a video that goes over a few of these things like normal forms.
Okay.
But do try to practice anyhow. I don't know where. I'm gonna guess mod 2 has normal forms in them. Anyways, I forgot about them because again, whatever. You don't need to know that.
Yeah, okay, that makes sense.
Yeah.
Perfect,
Very cool.
thank you.
You're very welcome. This is recorded and I'll send it out.
I was gonna say,
Yeah.
Thank
It's an
you.
hour and a half, so we'll have fun with that.
yeah,
Absolutely. Okay, sounds good. If you guys need any help, let me go over, give it a shot. Right, go through that midterm practice. Try not to look at the answers I flashed on the screen in that recording. Actually try to do it on your own. And then you can, again, my answers, those are my answers. They're not necessarily 100% correct. But if you get confused when you're writing that, don't just look at the answers and be like, oh, I get it now. You probably don't, because you didn't get it. Why would looking at the answer help you at all? So write down, hey, I didn't feel very comfortable with this, or I didn't fully understand why this was the answer, and reach back out. We'll go over it.
Okay, perfect.
And give us normal forms of practice.
Okay.
Sounds good.
Thank you.
Really. Talk to you guys later.
Bye-bye.
Bye.